Hey everybody, this is Jim with Harvest Harmonics and welcome to the Future of Farming today. And today I'm going to show you how you can increase yield with less inputs. More yield, less inputs. Yield, inputs, yield, inputs. More yield, less fertilizer, less pesticides, less inputs. Now here's the thing. I'm sure you guys get a lot of people telling you, making huge claims, making huge promises, et cetera. I can get you a 20% increase in yield, 30% increase in yield, et cetera. And I've learned the hard way that even though my technology can deliver that, it's not the best way to attract attention. So I'm going to show you why. I'm going to show you scientifically why we're getting these results. Okay, not just that we get these results. I'm not going to show you a bunch of pictures and fancy spreadsheets and all that stuff. I'm going to actually just show you exactly why our technology delivers more yield and also why it simultaneously decreases inputs. Okay. And the answer to that question really shouldn't be very complex. It's we're making plants more efficient. Okay. Efficiency is the amount of production you can get with the divided by the amount of work or input or effort you have to put in, right? If you want to be more efficient as an office worker, it's like how many phone calls can I take? How many emails can I send? How many, pieces of paperwork I can process in a given period of time, right? And so productivity with farming is not much different, right? It's how much yield can I get in per unit of input, right? I have a fertilizer cost, I have a pesticide cost, I have labor costs, et cetera, right? So you have certain costs which are somewhat fixed, and you have, well, some costs are fixed, like your land cost, your equipment costs, your fuel cost, a lot of that stuff is sort of fixed. But if you want to get more yield if you want to get more profitable, you have to get more yield with less inputs, right? If you just increase your inputs and get more yield to get more yield, then you're not increasing efficiency, right? You're just making more of everything you're doing. If you reduce your inputs, but you get less yield simultaneously, you're not getting more efficient, right? It's just you're getting less, but you're spending less. So you need to accomplish both of those things, right? Now, if any of that doesn't make sense, please stop this video or stop watching it and go back and I want you to like diagram that out if that doesn't make sense to you. It should be pretty obvious, okay? But I want to show you from a biological standpoint within plants exactly how we're accomplishing this without chemicals and why we're able to reduce the amount of chemicals you need, because in reality, the plants are not absorbing all the chemicals that you're using anyway. If you don't believe me, I want you to go out and Google or go into ChatGPT or something like that. And I want you to do a search for nitrogen use efficiency worldwide. And what you'll find out, it's probably the third or fourth listing, you're going to find out a report from 2014, which goes all around the world. And country by country, it shows you how much nitrogen is being used. In fact, I'm going to show you right now so you don't have to even do the search. I'll just do that work for you. Let me share my screen here with you and let you see. I don't know, let's go over here. Let's just type nitrogen use efficiency. So you've already done that before, okay? I'm gonna go down here. And where is it? It's Our World in Data is the actual site. There it is, Our World in Data, nitrogen use efficiency 2014. Now they only do these reports every 7 or 8 years now. It's been 9 years, so I assume they're gonna update this at some point. Now, when you look at this map here, you're gonna see on a country level how much nitrogen is being used and how efficient these countries are. Now, what this means is they take, the ratio between the nitrogen inputs and output. In other words, so the nitrogen being used in a particular country for agriculture versus the amount of productivity, and they get a sort of a percentage that way. Because if the plants were absorbing 100% of the nitrogen that you're using, well, that means you have 100% efficiency rating, right? However, even in countries like the United States, where everything is considered pretty efficient, you have what, a 71%. That means almost 30% of the nitrogen that farmers in America are using is not being used by the plants, okay? Look at other countries that are super efficient, like Angola over here, right? 83%, in the mid-African countries, Niger, 83, Chad, 87%. And Burkina Faso, I've never even heard of that country, 95%. They're doing pretty good. Indonesia, that's Singapore. Indonesia, 80%. Now, these countries that are super efficient, it's not just so much that are super efficient, it's that they really don't use fertilizer that much. They're using so little fertilizer that their efficiency looks like astronomically high. But in even developed countries like the United States, you see 70% efficiency rate. Brazil, huge producer, 57%. That means that they're wasting 42.5% of their nitrogen is being wasted. It's not going into the plants. It's actually going into the waterways. It's going into the atmosphere. It's just not getting to the plants. So what does that mean? That means that worldwide, if you look at the whole world, now granted, this was taken 9 years ago, but worldwide, if you look at those, in countries here that are nitrogen mining, like Russia, they actually export nitrogen. So they actually export most of their nitrogen. They don't use it for agriculture because Russia's a cold country. So you want to know what happened when Russia invaded Ukraine? Well, guess what? All that nitrogen that they were exporting to all these countries is now no longer being exported. So now you have the cost of nitrogen going way up, right? And that's one of the big reasons worldwide. Ukraine, same thing. They export a lot of their nitrogen. Well, not anymore, they're not. You know, unfortunately, that's a problem with geopolitical conflict. So let me get to the point of my little narrative here. The point is that in around the world, farmers are actually very, very inefficient in terms of the nitrogen usage, right? So that means that we have a long way to go in terms of making your farm more efficient to help reduce input costs and improve yield. So it's not like, you know, guys in America here who are farming and have everything what they think is efficient. It's not that they can't dramatically improve. They have a lot of room for improvement, even here in America, right? They can improve that efficiency, probably cut that in half and be up to 80% efficient. If they went from 71 to 80% efficiency in the United States, and that would mean that the average corn yield would be somewhere in the mid 300s instead of the mid 200s around the country. That means that all the fruits and vegetables that are being grown would be grown with about half as much cost as you're already spending. So hopefully, if you've been paying attention, hopefully that I've grabbed your interest now. If you were looking at how can I reduce my cost or how can I make my crops more efficient to get more yield, then profitability demands that you really balance those two factors. So having said all that, I'm going to show you our crop booster. Okay, and this is our crop booster, just so you know. Okay, if you haven't seen our videos, then go to our website or send me an email at service@harvestharmonics.com. I will send you the full walkthrough of how our technology works and what it looks like and all that stuff. I'm not going to go into that here because I don't really have the time, but I'm happy to share exactly how it works with you in a recorded video. Okay. Having said that, our crop booster is essentially a series of transmitters. Okay, you see a big picture of this orange circular dot here, this transmitter. This is actually a transmitter, a micro transmitter that's been programmed with over 3,000 programs associated with healthy plants. And they're biophysical signals, meaning they're signals that are designed to improve the physical interactions between the cellular functions of the plant, which makes them more efficient. Okay. Now, I'm going to walk you back here a little bit and show you photosynthesis. Okay. Now, in this picture here, you see in the slide, on the right here, you see a picture of photosynthesis. Okay. Now, this is just the common basic functions of a plant. We can, of course, get a lot more detail, but this is a basic series of things that have to happen for photosynthesis to occur. Now, if you don't know, photosynthesis is how a plant generates energy. It's how the plant utilizes the sun's energy to create sugar molecules, which of course the plant then uses for cellular growth and fruit growth, which is fruit and vegetable growth. Okay? So for photosynthesis to occur, it has to absorb water and nutrients through the root system, like you see in the bottom here. It has to transport those water and nutrients up to the leaves of the plant. And in the leaves of the plant, there's cells within the plant called chloroplasts that hold water and carbon dioxide molecules inside the cells. And then when the sun hits those cells, it actually becomes a catalyst and breaks apart those chemical bonds. You know, carbon dioxide is carbon and oxygen, right? It breaks apart that bond so that now you have free oxygen and you have carbon molecules, right? The oxygen, as you can see in the picture here on the right, gets respirated and exhaled by the plant. And of course, that's why we say plants generate oxygen, because that oxygen comes off, okay? It takes the carbon from that carbon dioxide molecule and mixes with hydrogen and oxygen and water, okay? And it creates a glucose molecule, okay? Glucose is a type of sugar, okay? So from that combination of carbon dioxide and water, you get glucose molecules. and for the plant to generate chlorophyll and other things in the cellular structure, it of course needs potassium, nitrogen, phosphorus, and other types of minerals. That's why we add the big three, NPK, okay? Because the plant needs other things besides just carbon dioxide and water to be able to generate cells, okay? Now, let me explain to you, okay? The more sugar a plant can create through this photosynthesis process, the more energy, chemical energy it has to be able to drive cellular growth, which grows the plant, and to drive cellular growth in terms of fruit and vegetable production, okay? The more energy a plant has, the more sugar molecules that plant can generate through photosynthesis, the more energy it has to create fruits and vegetables, which is, of course, exactly how the plant generates fruits and vegetables. That's how plants can generate energy, okay? So if you really want to know the secret to how to generate more yield in terms of fruits and vegetables with less inputs, the secret to that is make the photosynthesis process super, super efficient. Now, why is that so important? Because when you can dramatically improve the sugar production in plants, it does several things. First of all, it gives the plant energy that it needs to drive cellular creation, okay? Yes, it does need nitrogen. Yes, it does need potassium. Yes, it does need phosphorus and calcium and other minerals to generate cellular structures, okay? But how does sugar relate to that? Well, the root system of a plant can only really absorb what it can contact. And that's the roots will grow out, but they're only so long and they can only contact so much water and nutrients in the soil. So how can a plant increase the amount of nitrogen, phosphorus, and potassium that it can absorb through the root structure? The answer to that question depends upon microbial function in the soil. You may have heard of mycorrhizae funguses, which can dramatically extend the root system out into the soil by up to 95%. So we can more than double the effective root length, the effective root structure in a plant by improving microbial activity in soil. Okay, well, how do we improve microbial activity in soil? Well, you improve that by increasing sugar created through photosynthesis, because the plant will actually send some of that sugar that it's creating through photosynthesis back down through the root system in forms of starch and other types of sugar molecules, which will attract microbes in the soil and mycorrhizae fungi in the soil. And those microorganisms will then take that sugar and feed on it. They will grow and multiply and reproduce. And then they will go and extend, they form a symbiotic relationship. And they will go and extend that root structure into the soil. And they will find nitrogen and phosphorus, potassium, calcium, and other elements that the plant needs in the soil. And they will bring those nutrients back to the plant. So the plant then is able to get the other nutrients that it needs and get them efficiently by working with those soil-borne microorganisms in that relationship, okay? Now, if all this sounds really technical and really weird, I want you to know that this is how nature's been doing this for millions and millions and millions of years. This is not some new science or new understanding. This is how nature works. This is how nature works without mankind's intervention, okay? Before we started using fertilizers, what did we use? We used manure, okay? We had animals and they'd defecate, and that would provide nitrogen and other nutrients that the plants would need. And then, of course, it would work. But for millions of years, you had trees, you had bushes, you had everything in nature working together in harmony before we ever did anything with this. So that is how nature works. And what we've done with Harvest Harmonics and our crop booster is just look at that whole natural process. It said, how do we make that process so efficient? How do we use modern technology to drive that natural process? So instead of having to use chemical fertilizers and chemical pesticides and chemical herbicides, we're looking at it like, how do we just make nature's own processes more efficient? And that's what our crop booster does. Our system sends a tiny wave pattern or several tiny wave patterns into a farmer's irrigation water. When the plants absorb that, those internal cellular functions begin to be harmonized with their ideal processes and their ideal frequency. That makes the internal processes of the plant more efficient. And when the internal processes of the plant are more efficient, guess what? It generates more energy. That photosynthesis process is much more efficient. And that means that the plant will be able to produce a lot more of those sugar molecules with a lot less inputs and help from the farmer. And again, there's the key to efficiency. More yield, less inputs. More money in your pocket, less money to your creditors and the equipment companies and the chemical companies and the fertilizer companies. For those of you guys who are selling fertilizers and chemicals, sorry. No harm to you, no harm meant, but we're trying to help farmers here. So farmers out there, if you're watching this video and you want to get your farming operation more efficient, you want to do things in a much more efficient way so you can be more profitable and create a healthier, better quality product, and we want to work with you. So give us a call at 727-324-6750 or email us at service@harvestharmonics.com. And let's work together to help your farm become part of the future.